gosh, if you're like me, you probably never thought I was going to finish lesson videos for chapter 3, but we are finally on the last section. I'm going to knock it out in one video. So it's on density, something you probably learned before. So density is the ratio of the mass of an object to its volume. So its formula is density equals mass over volume. You'll see me write D equals M over V. Density is an intensive property. So if you remember from chapter 2, we talked about the difference in extensive and intensive. Extensive depends on the amount, so mass depends on the amount. Intensive depends on the type of substance, so color or density would be an intensive property. And it only depends on the composition, not the size of the sample. So when you mentally think of density, because sometimes the formula isn't enough to make you understand what it is, think of how close the particles are together and how much space they occupy. So see, these particles occupy most of this blue rectangle. Yeah, it's pretty much a rectangle. I don't think it's quite a perfect square. And this one, the particles don't occupy nearly as much, so this substance would have the greater density because there's less empty space between the particles. So that's the way you can, kind of think of what density is. The density of a substance generally decreases as its temperature increases. However, water is an exception to this rule. So ice is colder than liquid water. So technically, according to this rule, it should sink. But we all know that ice floats. We'll learn in a later chapter why that happens, but it's based off of hydrogen bonding and the arrangement of the structure of ice. But if you've ever watched the movie Tangled, which I love, you see them light the lanterns, the sky lanterns, and then they start floating off like tiny hot air balloons. So inside the lantern is just regular air. It's not helium. And so when they light the fire, it heats the air inside the lantern. The temperature increases, so it becomes less dense. And so that's what makes it float. If something's less dense than something else, it will float. If something's more dense than something else, it will sink. All right, and I just love that movie and I love that scene, so I had to put that in there. All right, so let's do some math, because I know that's everybody's favorite. It's definitely mine, for real. I was being sarcastic about it being y'all's favorite. So it says a copper penny has a mass of 3.1 grams, so there's my mass, and a volume of 0.35 centimeters cubed. What is the density? Okay, so density equals mass over volume. So they gave me the mass, they gave me the volume, so I just plug in. So my mass is 3.1 grams, my volume is 0.35 centimeters cubed. So I divide. When I divide, I get 8.86. Now, is a gram and a centimeter cubed going to cancel? No, because they're not the same thing. So I keep both units. So the unit is grams per centimeter cubed. For density, you'll always have a double unit. Okay, it doesn't have to be grams and centimeters cubed, but you'll have a mass over a volume for density. All right, so hopefully you've done this before in physical science, and so this is just kind of review. So let's move on. So if you already feel comfortable, maybe pause the video and try a few of these. Otherwise, we'll look at a couple more together and then you can pause it. So it says a bar of silver has a mass of 68 grams and a volume of 6.48 centimeters cubed. What is the density? All right, so again, we're just using density equals mass over volume. So then I just plug in. So my mass is 68 grams. And my volume is 6.48 centimeters cubed. So I just divide my two numbers. I get 10.49. And then again, a gram and centimeters cubed does not cancel. So I keep both units, just like that. So hopefully you got that one right if you tried it on your own. Now let's look at how to rearrange the formula. A lot of you struggle with that. And if you learned the magic triangle method from physical science, that's fine. It does work for this formula. However, it doesn't work for all formulas, so I will not be teaching it that way. If you know it that way, you're more than welcome to use it, but I teach the rearranging way that works for all formulas. All right, so it says a substance has a density of 0.38 grams per milliliter and a volume of 20 milliliters. What is the mass? So in other words, we're not looking for density. We need mass to be by itself. Whatever you're looking for should be by itself. All right, so density equals mass over volume. We want to know what mass is. So to move something to the other side, like we don't want V on this side anymore, we want on the other side. You just do the opposite mathematically. So see, right now we're dividing by volume. So what's the opposite of dividing? Multiplying. So if I multiply both sides by volume, then see how it's on top and on bottom, so it cancels? So mass equals volume times density. Okay, if you need help rearranging a formula, that would be something to come see me during tutoring for, because I don't have a lot of class time to go over this. This is something that technically you're supposed to know before you're in this class. All right, so mass equals volume times density, so then I just plug in. So my volume is 20 milliliters. My density is 0.38 grams per milliliter. Now, I know some of y'all like to write it with a slash like that, but when you're doing math, it really helps if you actually write it on bottom, because then you can see that they cancel out, because 1 milliliter is in the numerator and 1's in the denominator. So I just multiply my two numbers. So when I multiply, I get 7.6, and then the unit that I'm left with is grams, which is a unit for mass. All right, so let's look at the bottom one. So again, if you haven't tried one on your own, make sure you pause and try it. So it says, this one's a little tricky, I will tell you that. It says a metal block has a density of 0.66 grams per centimeter cubed and has a mass of 2 kilograms. What is the volume? All right, so first of all, I'm going to need to rearrange my formula, but what's the other problem? 0.66 grams per centimeter cubed, but then I gave you 2 kilograms instead of grams. So I also need to change kilograms to grams. Now, hopefully you're comfortable with section 3, because I'm not going to go slow on this one. Okay, we're going to convert kilograms to grams. So I start with my 2 kilograms. Golden rule says my kilograms goes on bottom. Since that's the prefix unit, it has the 1. My 10 power for kilo is 10 to the 3, and my base unit is grams. Okay, if you're having trouble following that, you need to go back and watch section 3.3 some more, because that's where I show you how to convert. Since both numbers are on top, I multiply and I get 2,000 grams. So that's going to be my new mass, because see, now grams and grams are the same unit. Okay, I don't try to trick you like this very often, but just be careful of that kind of stuff. But I'm going to solve for volume. So density equals mass over volume. So a lot of people, what they do first is they want to divide both sides by mass and say volume equals density over mass. The problem is you cannot solve for something in the denominator. You have to have it in the numerator. So what I actually do first is multiply both sides by volume. Because see how what that does is it puts it in the numerator. Once you have it in the numerator, then you can get it by itself. So here, I'm just going to rewrite it because it gets a little sloppy. So we're trying to solve for volume. So what's the opposite of multiplying by density? Dividing by density. So I divide both sides by density. So volume equals mass over density. Again, if you're having issues rearranging, come see me for tutoring. All right, so volume equals mass over density. So I'm going to use my new mass of 2,000 grams and my density of 0.66 grams per centimeter cubed. So as you can see, your grams cancel and you're left with centimeters cubed. And once you divide, you should get 3,030.3, and your unit you're left with is centimeters cubed. Okay, so like I said, you've got to make sure you know how to rearrange a formula properly. We're going to do a lot of that in the second half of this class. All right, so let's erase and move on. All right. So here are my answers and section assessments. See, this section actually wasn't a million slides long. So what determines the density of an object? Well, the mass and the volume, because density equals mass over volume. So it's the ratio of the mass to the volume. How does density vary with temperature? Normally, as temperature increases, density decreases. Or you can say they're indirectly or inversely proportional. However, remember, the exception is water, because ice floats on liquid water. All right, so let's knock out these real quick. So it says a weather balloon is inflated to a volume of 2.2 times 10 to the 3 liters with 37.4 grams, which is a mass, of helium. What is the density? So since I'm solving for density, I don't even have to rearrange the formula. I can just plug in. So density equals mass, which is 37.4 grams, divided by volume, which is 2.2 times 10 to the 3 liters. All right, one side divide that. Let's see, which one am I looking at? Okay, I get 0.0 0.017, and then my unit is grams per liter. So see, just notice that density can have different units. All right, so make sure you're paying attention to what you get in the problem. All right, so number 4, it says a 68-gram bar of gold is cut into 3 equal pieces. How does the density of each piece compare to the density of the original gold bar? Well, in other words, what we have is just a smaller piece of gold. How would the density compare? Most students will tell me it's lower than the density of the original gold bar. But remember, density is intensive. It just depends on what the substance is, not how much. So you started with gold, you ended with gold pieces. Are they still gold? Yes. So density remains the same. Okay, because it's an intensive property. Now the mass would be different, the volume would be different, but like the color of the gold is the same, the density of the gold is the same, the melting point of the gold is the same because it's still gold. All right, so last one, it said, or I think this might be the last one, we'll see when I click. A plastic ball with a volume of 19.7 centimeters cubed has a mass, here's my volume, of 15.8 grams. Would this ball sink or float in a container of gasoline if the density of gasoline is this? So first we need to figure out the density of the plastic ball. So density equals mass over volume. Whew, I didn't give myself much room to write down here, did I? So my mass is 15.8 grams. My volume is 19.7 centimeters cubed. So once I divide, I get 0.802. And then my unit would be grams per centimeter cubed. But that's not what they're asking for. They're asking would it float or sink. So gasoline has a density of 0.675. The plastic ball has a density of 0.802. Since the plastic ball has the higher density, it will sink. Now if it had a density less than the gasoline, it would float. But since it's higher than the gasoline, the ball would sink. All right, so let's move on, possibly to the end. Two more. Well, one more, because one's for honors. All right, we can get through this last one. So it says, what is the volume in cubic centimeters, so we're looking for volume, of a sample of cough syrup that has a mass of 50 grams. The density is 0.95 grams per centimeter cubed. All right, so remember, density equals mass over volume. We're solving for volume, so the first thing we need to do is get volume in the numerator. So I'm going to multiply both sides by volume. So see now, volume times density equals mass. I'm still trying to get volume alone, so I'm going to divide both sides by density. So volume equals mass over density. Once I know that, I can solve the problem. So volume equals mass, which is 50 grams, divided by density, which is 0.95 grams per centimeter cubed. So if you look, those grams cancel. I'm left with centimeters cubed in my answer, and when I solve, it's 52.6 centimeters cubed. All right, so, that was chapter 3. Lots of math, because you need lots of math skills to get through the rest of this class. All right, hopefully it wasn't too terribly painful. It was kind of painful making all these videos, but that's okay.